Yeah, hello, good evening to all. Hello, ma'am, are you there?
Good evening, sir.
Yeah, good evening. Yeah. So, shall we start or can I wait for 2 more minutes?
Yes, sir, you can start the session.
Yeah, ma'am.
Thank you.
Yeah. Yeah, hello, good evening to all. And now we are going to discuss about the sorting techniques. And in the last session, we have discussed some of the sorting techniques like bubble sort, selection sort, and insertion sort, right? So I think in the insertion sort, for all the sorting, we have shown some execution of the program also. But in the insertion sort, I have given you to do some kind of assignment. I don't know how many of you have completed. Okay, let me run this program today, insertion sort. So before going to write the program, I'll give you just a refresh of how to do the insertion sort technique, right? So based on the keep in your mind of about the logic, then we will write the program. Okay, that is the today's topic, insertion sort. Followed by very good important topic is merge sort. Okay, with that I will stop the sorting techniques, and the rest of the sorting techniques you can also practice with this knowledge. You can also practice here by your own. And then immediately I will move to the stack operations, right? Stacks, queues, and all. Okay. So I'll show you where is this is all about selection sort. Selection sort I have shown execution also. Now I want to show you insertion sort. Yeah, this is the insertion sort. Okay. So in this insertion sort, what we are doing, I'm just identifying the list element and then keeping into, I'm inserting a respective position. The immediately followed by the next element. Okay, we are identifying. See, if you take this element, this is ordered and this is unordered list, right? From this unordered, I'll take one by one, and then we are keeping into in the ordered list where you want to insert your values. Okay, now I'm just identifying this value and I'm checking whether this value is less than this, like minus 12 is less than the 12, then I'll keep into, I'll arrange, and then I'll keep away this value 4, and then finally I will insert my element before that. Likewise, I'll take from the unordered list the 11. Okay, now these are the two lists we have, two arrays. One is ordered array and this is unordered array. From this ordered, I'm going to check all the elements, okay, where I want to insert, whether is this less than this. Yes, if it is less than, I'll just move ahead. And is this 11 is less than the 4? No, then I'll put into the next to that value. Likewise, very simple. Okay, I'm just comparing here whether the value is less than the given value or not. Then I'm going to keep into the particular location. That's it. Same thing, I need to apply all the elements by considering ordered and unordered list until completion of all ordered list. All the elements will get ordered. Yeah, here you will understand better in this one where I want to insert this one here. And then finally, all the elements will be get inserted. Okay, so this program we are going to execute. Yeah, let me start. Yeah, so example program on insertion sort. Hash include for every sorting techniques. What is the first thing? I'll write my main program. You just give an array as an input and the size of the array and read those elements. Okay, so you can implement using the functions or without functions, right? Anyway, you can use. I'll make it return 0 so that I'm not writing any functions here. Simply I'll do all together in one program. Whatever the variables I'm using, I, j, to get the size I'm reading into the n, and I need some temporary variable and I want some array. I'll take the array size is 20. And printf, enter the size of the array, right? Enter size of array. How many number of elements you want to enter into that array? That I'm going to store into, this is common for all. I want to store into n. That means what? You need to read n number of elements, right? Immediately it should ask that many number, n value, whatever you are given, enter that many elements, right? So I can say enter how many elements? %d, that means n value. Enter n elements. After that, I will read you need to read elements, right? So you know how to read n number of elements. I less than n, I plus plus, right? Then I can say scanf %d ampersand of I. So now you just read a number of elements is over. What is the next step? We should implement once your array is ready, we should write the program for insertion algorithm, right? So now implementation of insertion sort algorithm otherwise. Okay, yeah. So how I'm going to implement here? My array should start with either if you write 0 to n minus 1, or I can say I equal to 1. That should be I less than n, right? Both are same. When I can start with 0, it should be n minus 1. If I start with 1, it will be n less than n. So the first element, first means this is the here it is second element it comes, right? I need to compare two elements, first and second. So my loop is going to start from second element onwards. I can say I want to store AFI value. That means AF1 value, right? AF1 value I stored into temporarily. See, every time while you are comparing two elements, you need I and J. Okay, two elements will be there. So I is second element and J is first element I'm considering here. So that's why temporary equal to AFI. That means AF1. That is equal to second element. So I'll keep I minus 1. That means before that element. This is before that element. Okay, that before that element, I'm going to check the condition. What is the condition here? While temp less than A of J, your temporary value is less than the A of J, and that means until which location I am moving. I have moved, right? Say if it is not less than, then I am just moving where I want to stop. Okay, yeah. If this temporary value is less than the A of J and J greater than or equal to 0. Yeah, first time it is okay. J value is greater than or equal to 0. And then I'll keep A of J plus 1 equal to A of J plus 1 equal to this. All how you are going to practice? You just take what is I value, what is J value, iterate. Now what is J becomes, okay, and what is the condition? Like this, I told you, every program you should compare. Okay, then this is like just I'm keeping away of this all the elements. Now where is your element? Temp. This temporary element I want to put in somewhere. Where I want to put? Into this location J plus 1. I want to put into my temporary location into J plus 1. Okay, you just take all the variable values. If I explain like this, entire time it will take for only one program. Okay, so I told you in the last class, you take I variable, J variable, and a temporary, and what is the value and what is the condition where it is moving. I keep aside all, and where I want to store this element. Okay, then go to the next element, and then this is a process of keeping aside where I want to insert this element. Okay, so whatever you are considering now, it is the third element you take. Then this element I am keeping into separate temporary. Those elements I will put into which location you want. You keep aside of all the elements. Like this, block wise you understand. Okay, you take every element, put into temporary. That means from the temporary I want to put somewhere location. In which position I want to put, keep aside of all these values, and then place if the value is less than or not. If it is okay, then keep away. And then finally, if it is wherever it is, you feel that you want to insert that particular value, until that you have to move, then finally you have to assign this particular location. Okay, finally you have to print it. Printf order of sorted elements. I can say the sorted elements for I equal to 0, I less than n. How to print the array? Simply n values you want to print, I equal 0 to n, I plus plus. Print of percentage I. That's it. I can say maybe percentage 5d. Comma 5. That's it. I'll just print the final after sorting the elements. Let me save this. Insertion sort.c. Let me run this program. So the first one is I just given the size of the array. And then with that size, that many number of elements I'm reading into that array. Once the given array is ready, I have applied the insertion sort technique. And then I just printed the sorted elements. And now let me run this program. Yeah, I didn't close this. Yeah, enter the size of the array. I may give you the 5. Enter 5 elements. 12, 3, 4, 1, 7. Right? Is that values are in zigzag or not? Yes. And then sorted elements are 1, 3, 4, 7, 12. Okay, the elements are arranged in the ascending order. So you can identify the logic and you can trace the program with where is controlling moving and what is I value. Then you have to iterate, then you will understand very clearly. Same how I have explained bubble sort and selection sort. Okay, now similarly I will explain merge sort also. This is already yesterday's we have explained. So I just given the overview now. Now coming to next to sorting, we go for merge sort. What is that? Merge sort. See, this merge sort is also very important. So in this merge sort algorithm, this is the last sorting technique I'm going to explain. And next we will move to the next like stack operations and all. So in this merge sort, okay, what we are going to do? I'll tell you overview of this merge sort. Okay, here we are going to use divide and conquer method. What is the divide and conquer method? In the merge sort algorithm, we are going to apply a divide rule and conquer rule. What is the divide rule? Divide rule is nothing but divide the array into 2 subarrays recursively. That means, okay, you know the recursive functions. That means applying the same function number of times, the function name itself is same. That means automatically it will apply splitting that array into a small individual subarrays. Finally, it becomes one element in the array. Till that, it will split all that entire array. Say, for example, if we have 6 elements, it will split. How it is going to be split? That we will see. We have left, right, middle, and we find the middle element, and then based on the middle element, I'll split it. Then finally, you should know how we did in the bubble sort. Similarly, you identify the left element, right element, and middle. Calculate both left plus middle by left plus right by 2. Then though both are 2 separate arrays. After that, again you split till every array consists of 1 element. After that, you combined. Okay, that is the small logic that we'll see. With that logic, how we are going to apply the sorting technique. Then sort these subarrays recursively with merge sort again. This is one way. After that, followed by conquer. If there is any, during this conquer technique, if there is any, sometimes in the subarray, only 1 element will be left. Okay. Then at the time, we can use insertion sort again. Now, in this conquer, we should merge the subarrays to get final sorted array. How it is going to be happen? I'll show you with practically. See here in this divide phase. First, what I'm doing, I just consider like this. Why it becomes 4 plus 4 is one array and 3 elements in another array? You know that L is 0, 0, 1, 2, 3, 4, 5, 6. Right? So 0 plus 6 by 2. How much? 3. So 3 is the middle point. So middle 3 is the third index, right? 0, 1, 2, 3 is the index middle. Okay. Till mid, L and mid is one array, and mid plus 1 and R. This is another array. I am repeating. L is starting, R is ending. L equal to 0, R equal to n minus 1. Are you clear about L and R? Fine. And then 0 plus 6 by 2, M equal to 3. Fine. That means the first array is referred by the L and M is the middle. M is 0.3. The second array started with M plus 1 and R. Like this, we have two separate. The same logic we are going to do in the program also. Fine. Now let's see. I splitted these two. That is called divided. Okay. After this, again you take in this two subarrays. Again you consider this left portion is L, same formula you apply, L, R. 0, 1, 2, 3, 3 by 2, 1, right? 3 by 2 means how much? 1.5, it returns 1. So M value is 1. So 0, 1, right? So this is the midpoint. Okay. And similarly, you apply the same technique. Apply the same technique. Apply the same technique, and finally, same, this is one array, this is another array. Again, you split this. Again, you split this. See, this is leftover. This is leftover. We'll see leftover what we can do. Again, these two, everything subarrays, right? Yeah, everything again I'm going to split. 0 plus 1 by 2, okay, is 0 only, right? So this is 0. So that is the middle element. Then again, I'll split. So that's why if I split all together, what happened? 32 is one element, minus 2 is one element, 0 is one element, 3 is another element, like this, right? Yeah, I'm not sorting, right? Here I just make it as a splitted. So is this resultant data? No. Now at this moment, the array is not yet arranged in a specific order, right? I just make it splitted of each and everything. Same divide technique I applied recursively, so that same formula will be applied, and like calculated middle and left and right and middle point, and that middle till middle L comma, the middle is the one array, mid plus 1 and R is another array. Same formula will be applied. Then, okay, theory we'll see later. In this conquer phase, so this is the thing is happened, right? Okay. After that, what happened? Internally, this left side, all the elements are arranged in the sorting order, and these elements are arranged in the sorting order. Assume we have two subarrays. How I'm going to merge these two subarrays again? So first I will take a temporary array where I want to keep all the merged data. How I'm going to keep all the merged data? Now I'll put one here. See, I just selected this element and this element from the both arrays, and I'll check the which one is less, and that element I'll put into the resultant array. I'll check these two elements, which one is the least element, that I'll put into the third party array. And again, I will take another element. Why I'm taking this one? Assume that this is also is less than this first one. Then I'll put this only. Till what time I will move this? If this element is less than this first another array in the first element, till that I'll keep all the resultant values in the resultant array. Now I checked with this. Is this element is less than the 3? No. Then I'll stop. Then I'll keep this array. This array means left array, right array, you can assume. So I'll put 3 here. Okay, don't worry, end of this you can understand. Then this is okay, kept, right? Now where I have to move? Either this pointer is move or this pointer should move. Okay, this is less, right? That's why I kept here. So until what time I should move? Okay, yeah, again the condition becomes false. So that's why again I move to the 5. So here I move to here. So again, you compare these two. Okay, still, if you assume that this is still is less than, then you keep this. Again, you move left side. Still, this is less than this element. Again, you put here like this until you, if this element is less than that of this left array, all the elements will be placed. But it is not happening like that. Okay, then I will stop. Now I'll put this value here. You don't think whether simply 4 you have to put, 5 you have to put like that. You understand the logic behind that. Where I have stopped until where my mouse pointer, like my pointer is moving in which array, how many times, then your program should stop the logic. Right? You don't think that now I want to put 4, I've done 5 and 6, since you know the numbers, but the system don't know, right? That's why you should understand the logic. Okay, now I kept 4, fine. Then now which element I have to compare, you tell me. With 8 I have to compare with 5 or 6, shall I move to 6? Yes. No. Yeah, can I expect in the chart window? Can I expect in the chart window? Now, can I check with 8 and 5 or 6 and 4? Based on that, you can understand the logic. Okay, fine. I am moving. Yeah, I'm going to check with 8. Why? Because, okay, again 8 also, if it is less than that, I could have keep here until end of this. So now this is the less than. So that's why, okay, meant this is greater than this value. I am going to keep 5. Now which element I should move? Again in the left array only, right? In the left array only I will move 6. Now again I'll compare. See here, I'm comparing 5 with 8. Then still it is less than. I'm keeping the 5. And then I'll move left side only. Till what condition? Till the condition becomes false. What is the false? Is it less than that? Yes, true. Then I'll put in the resultant 6. Next, is this less than that? Less than means, is that left side array is less than the right side array? No. Then that right side will be moved here. Right side element will be moved. So this right side element will be moved. Okay. Now, I don't have any elements to move again. Otherwise, if we could have elements, then the right side 8 will be moved. Now, no. Then that's why I will check with, obviously, 10. 10 will be moved. Right side will be completed. So that's why the rest of the elements will be placed in the resultant. Yeah, that's why this is the way we are going to merge. So conquer nothing but merge. Conquer nothing but merging of two arrays. How I am going to merge of two sorted elements, my dear. This is merging of two sorted arrays. So in this array, this is in sorted order. In this array, this is in sorted order. When you have two sorted arrays, this is the procedure I should merge. That procedure also I should use here. Okay, finally, all the elements are in sorted order. So, yeah, I think this logic also not that much required. So far, I explained that's okay. If you want some more, for more better understanding, you can see with some of the examples like, okay, otherwise it is not required. Same thing explained in another manner. Okay, let me run this program. I'll take new and yeah. Example program on merge sort. Hash include stdio.h So here there are different cases. Okay, we have merge sort, merging, and then finally reading and printing. These many techniques you should identify. So what I'm going to do now. So here you should understand very clearly, it's a very big program. Okay. So first I'm writing the main program logic. Then see here what you should understand. Okay, I'll tell you. Same the logic you should understand here. Okay. See, before this, before doing merging, you should take this is as we discussed in the first phase, divide phase, we should divide everything, then you should sort it again. That is one phase, divide phase. After sorting, you should apply one left array is you will get finalized. That should be in the sorting order. This is in sorting order. How we did this one? Merge sort technique. So this is for merge sort. Then left side array. Then right side array is merge sort. Then finally, I should apply merge operation. Okay. So we should have merge sort operation, and that means sorting operation as well as merging of two sorted. There are two separate functions are required. Okay, let's see all the functions individually. So that's it. To better understand this, I'm using functions concept. So first I'll take some array. I will initialize with some elements. Okay, anything you can mention here. Maybe some values 10, 14, 4, 3, 6, something, any value you can give. And then, as you know, once if I'm using functions, you should know the number of elements in the array. How can you find the number of elements in the array? That is array size. I can say array size is equal to size of array by size of array of first element, right? Anything of 0. Yeah, and then you just print the given array as it is, right? Print given array. Otherwise, array before sorting. Array before sorting. I'm just printing array before sorting. For that, I'm using some print, right? I can say, instead of getting confused with print and printf, I can say print array. I can say print array. What is that? Array I'm passing as an argument, and array size. In the last class, we have observed this one. For every time I'm passing array and as well as array size. After this, what are the things I should do? I will apply merge sort. Okay, I will apply merge sort. Okay, merge sort. In this, what is the input? Array, and I'm passing initial value 0 and array size -1. Okay, that is number of elements 6 means array size is 0 to 5, right? That's why I'm passing 0 comma any elements. You can pass 10, 20 elements, then it will pass 0 and n-1 elements. So with this, I'm going to apply the sorting technique. And then finally, I will get my sorted array, right? So I'll print sorted array, printf sorted array. Okay, in this sorted array, I'll just print the array. What is that printing statement I'm using? Here I'm printing print array comma array size, right? Same thing, I'm using the function print array, right? So this is actual program. So, but you want print array code function definition and merge sort, right? So you should do, okay, merge sort. How you are going to do the merge sort technique? Again, within the merge sort, I should also call merging function. Okay, so let's see how I'm going to call the merge sort and merge. Yeah, so let me call merge sort. Okay, if I call merge sort, what is this? Given array. What is this? 0. 0 is the left position. What is this array size minus 1? That is n minus 1, right? N minus 1 is the R position. As I told you, I'll take paint. I'll take paint. Then you try to understand something, any values, maybe 18, 10, 14, 4, 3, 6. I'm passing total array. And then 0. 0 position is this one. This is the 0 position, right? 0. I will call as a L. I'll call it as a L. So that left array. It is n minus 1. N minus 1 means what? 0, 1, 2, 3, 4, 5, right? So this I'll consider as a R. This I'll consider as a R. Okay, then I will calculate middle. Okay, then I need to calculate middle. Okay, let's see. So same these parameters I should pass to this. This is L and this is R, right? I should pass to the array. I should pass to that. Like my this is actual parameters. I'll use as a formal parameters. Okay. Then what I'm going to do? Void merge sort. I'm not returning anything, right? Here I'm not. If I assign to any variable, then I should use some data return type. I'm not returning anything here. Simply, I'm going to create void. And what is an array first argument? Second argument I'll consider as a L. Third argument I'll consider as a R. Okay. In this merge sort, what is the technique I'm following? Always I used to check. The first thing is always left value is less than the R, right? Left position is less than the right position. That should be like that only. Okay. Always left position should be less than the right position. By default, now it is 0 and less than 5, right? 0 less than 5 is true. Then I can say, then inside what I'm going to do, I want to create another variable middle. Yeah, you can use two ways here. You can use m equal to L plus R by 2. M equal to L plus R by 2. That is one way. Sometimes, to avoid some kind of workflows, what I'm going to do, L plus R minus L by 2. Otherwise, I'll run this program with L plus R by 2 also. Okay, we can get it. Then, after finding the middle point, I need to sort. Okay, I'm applying the recursive function. Then merge sort of. How can I divide? Two arrays? See here. Assume that it is 5 plus 0 plus 5 by 2 is 2.5, nothing but 2. Okay, so this is the middle. This is the middle. So now what I'm going to do, I want to consider this is one array. This is one array. This is another array, right? This is another array. So how I'm going to write? This starting index is L. This ending index of the first array is the M. So what is the starting index of this? This I can say simply M plus 1, right? For every array, I should give starting and ending index. So what is the starting index of the second array? M plus 1. Ending index is the R. Same thing I am applying. Okay, for the merge sort, I am giving you the input array. So in case of recursive, the recursive function is nothing but what? Same function name I am using, but I am passing L array, one argument. What is the L? What is the R? So here L, and the third argument is I can say M. So that is one total array. So I can say merge sort of array comma L comma M. That is one array. L comma 1 is the one array. Try to understand. Now tell me what is the second array? Now tell me what is the second array? Again, I will call merge sort. That means recursively I am calling merge sort of array comma. What is the middle first index? M plus 1 is the first index, comma R. Ending is the R, right? So this is what I said now. This is what I said. Okay. So array, this array, how can I treat as a separate array? So starting index is the L, ending index is the M. So that internally treated as a separate array. Okay, then this the starting is the M plus 1 and ending is the R. So this will be treated as separate array. Again, these values will be passed here. Again, it will be considered as a, within this again we have to consider as the middle. Again, we have to split. Like this we should do, right? So till every element has single value. That means this condition until left is less than or. Fine. Now this is the way we can call the merge function, merge sort. Finally, these two elements will be sorted till you have used the merge sort as a recursively. Finally, what you should do? You should merge. Now you think that after calling the merge sort function, recursive function, the two individual arrays are in ascending order. Finally, what you want to do? You need to merge these two. So for that, I'm applying one function, merge function. In this, my input is total array and left and middle and R. These parameters I'm passing as an argument. Left index, middle index, and R. So that I'm going to merge these two. With this input I'm giving, how merge will apply, we'll see. Okay, fine. And then here, what is required? We need merge. How it is going to be applied merge is the important. Now let's see how I'm going to do merge function. Yeah. So this is the complicated merging of each and everything, right? Identifying this first element or second element, moving to left side element should be moved or right side element should be moved until where it has to stop, and everything will take place here. Okay. So how I'm going to merge? So I'm using another function called merge. Void merge. I'm giving you 4 arguments, right? One is array, and then left. Sorry, this should be here, right? Yeah. Left and middle and R, so that it is easy to understand. Yeah. So now in this, what I'm going to do, I'll take some variables, I, j, k. Yeah, first I'll write this, and then finally you will understand. You can trace it with what is the initial value, and you take another variable n1 and n2, and after that you calculate with what is m value, what is l value, and what are the. I'm going to create actually n1, n2 with the total size I'm taking. Okay, so n1 is one array, left side array, n2 is the right side array, n1 is the left side array, and that middle minus l m minus middle minus left plus 1, that is n1 is one array, n2 is another array. Okay, so ending minus m, then you will get the second part. How I'm going to get the first part and second part? How I'm going to get the first part and second part? Okay, second part I'll get r minus m, middle, okay, ending minus m. So I will get the index value of the n2. Then total size actually, okay. So I need to create 2 temporary arrays. Create temporary arrays with the sizes of n1 and n2. That is my intention. So I can say, okay, L and R I already used in the lowercase. So I'm going to use a capital letter or anything left array, like that you can use anything. I'm going to use capital L for left side array with the size of n1. With the size of n1. And this is little bit complicated. Try to understand. Later you'll get it. And again, I'll repeat the same program. Okay. So first let me complete this. So I just decided created 2 temporary arrays with the size of n1 and n2. I don't want total size, right? That's why how much size is required for left array and how much size is required second array. That is my intention. And then copy data to temporary arrays L and R. Okay. I'll just copy data to temporary arrays. L is one array and R array. I just copy. How I'm going to copy? With the size I told you n1, right? Simply n1 nothing but what? For I equal to 0, I less than n1, I plus plus. n2, I j equal to 0, j less than n2, j plus plus. I'm going to write this, I equal to 0, I less than n1, I plus plus. With this size. Why? Because I said n1 size, right? So that is this much of the size. All the indexing values I'm going to copy into L array. Now I equal to, already the values are there in the array. L plus I. Similarly, I will copy into R. So how I will do? I'll just copy this. I'll do for j equal to 0, j less than n2, j less than into j plus plus, r of j equal to array of m plus 1 plus j, m plus 1 plus j. Yeah, now how I'm going to merge these two elements. So again, I need some initialization, I value 0, j equal to 0, k equal to L. While I less than N1 and j less than N2, till that condition is true, I'll repeat all the values. If L of I less than or equal to R of j. I think this program is a little bit complicated, and I can also show you another way very easily. How can you do this? First, let me finish this. And then array of k equal to L of I. And then I plus plus. Else array of k equal to R of j. Then j plus plus. Then I will increase the k value. And then copy the remaining elements of L. So as I said earlier, if there is any some elements are empty, then at the time I can use this one. So for understanding purpose, copy the remaining elements. To copy the remaining elements, what I'm going to do, while I less than N1, array of k equal to L of I plus plus, and then k plus plus. So if any elements are pending with, copy the remaining elements of the left side array, and the same thing, copy the remaining elements of the right side array. In the right side array. So what I'm going to do, same thing I'll copy. Same thing I'll copy here. I can say simply J is referred N2. So left side L of and right side array R of J. J plus plus and K plus plus. Yeah. That's it. Yeah, and then finally we have printing function. Okay, we just missed the printing function. Simply I'm going to print array. The program is over now. Print array. Whatever you are passing any array, I'll create is a formal argument. I can take size. And once if you know the array, if you know the size, how you are going to print for I equal to 0, I less than the size you are passing, I plus plus, and then simply I'm printing printf percentage 5d id comma a of I. This is a simple statement we are using for printing. Okay, that's it. This is the printing function. So finally, as an overview, if you look into this, as an overview of this program, okay, you can understand what are the various portions of the program. Okay, so what are the various sub functions we have? First, we'll see only the outline. First, we will see the outline. See, in this main program, first I have divided into very small thing like your actual program. So you are given the given array and sizes, and I'm going to print it. And for printing, print array and merge sort, right? While you are passing values into the merge sort, here we are using inside merge function. Okay. So in this again merge sort, okay, I'll make it two individual functions, two individual subarrays are sorted order, and then I'm going to merge it. Till that it is over. Control will move from the merge. Control will move to here while merging. Merging, you already identified something logic like what is the left array, what is the right array, and identify whether it is the left side is less than the right side, and then I'll copy this into this array, and then I'll increase the I++. Otherwise, I'll copy the right side value into the array, and then J++. Okay, finally I'll move the K++. Then I'll move here. Likewise, continuously I will do. What is this operation? This one. Like whether I have to move the left value and I moved right side and then check with the left side value. And now where I have to move till the condition is true. Okay, like this, what we have observed in the previous case, right? So that is the two separate parts. This is for left and less than or equal to R of J. Then I will move the left side. Otherwise, I will move right side value. This is the resultant array, right? In the resultant array, which array value you have to keep? Either left side array value you have to keep or right side array value. If you observe the overall program, it is very easy. Okay. So which side array in the resultant, which side array elements you want to keep? Either left side array element or right side array element. You understood now? Then immediately I'll increase the I++. And here J++, and immediately in the same, in the right side, always the right side element is pointed by the J, and left side I'm using I. I'll move the left side. Still if the value is same thing less than, then again the left side value only I'll put into the resultant array, I'll increase. If this is not false, then immediately right side element I'll put here. I think, do you understand of this logic of merging? Okay. So this is the value I'm using. Either I want to put either 8 element into the resultant or 10 I want to put. Okay. So based on the condition, the less than or greater than. Okay. Is the left side value is less than the right side? Is the left side value is the less than the right side? No, right? If it is true, I can put the left side value here. So this is false in this case. Now what happened? Right side R of J, this is R of J value, this will put into here and J is incremented. Still, if you have some more, you can move. Okay, like this. Okay, fine. So I always, you should check I less than N1. The N1 is the maximum size of this left side array, and N2 is the maximum size of this one, right? Till that you move both, conditions should satisfy. Okay, so this is the way we can apply the merge operations. If you observe individually, you can understand. Now let me run this program. Merge.c. Yeah. See, directly I'm printing array before sorting, and Sorry, I didn't call the array after sorting, I think so. Yeah, let me run this. Let me run this, execute. See here, the given array is 18, 10 something, and sorted array, the elements will be in sorted 2, 3, 7, 10, 15, 18. Okay, so you try this by how you're going to try. Simply take the values, elements, and as we have shown in the last class, arranging the elements, what is the current value of ij, and take two different arrays. Like that, if you trace, if you practice, then you'll understand very easily. Now, till that, sorting and searching techniques are completed. Now let us move with a new topic called stack operations. A new topic called stack operations in C. Okay. So I'll tell you what are the rest of the topics we have. We are going to cover in these data structures. We have linear data structures, we have non-linear data structures, right? As part of the data structures, we are going to cover what are the various operations. Stack, what is a stack? How to implement stack using, okay? What are the various types of stack operations? Okay, what are the various stack operations? So this is stack operations. What are the stack operations? Like push operation, pop operation, okay, is empty, is full, and display, and so on. Okay, so these are the various operations we are going to see in the stack operation. So these operations we are going to see implementation of stack using implementation of stack. We can implement the stack operations with arrays as well as linked list concept. So implementation of stack with linked list. So till now we don't have the concept of linked list. So what I will do, first I will complete the implementation of stack with arrays so that you should feel that it is easy for you. There is a new topic, linked list. At the time I can show you stack with linked list. That means I'll tell you here. The next we have queues concept. Same thing, implementation. What are the operations of the queue? Okay, operations of queue, and then implementation of queue with arrays as well as and linked list. So linked list, I'll tell you after the topic called linked list. So in this linked list concept, again there are different types. One is singly linked list. We have another one is doubly linked list. And the third one is circular linked list. After that, the same in this linked list, I'll tell you after introducing the linked list concept, then I will explain how to implement the stacks with the linked list, how to implement the queue with the linked list. Here again, you can see various operations, how to insert, how to delete, where you want to insert, either starting insert or ending insert, or wherever you want to insert in the specific position. Like this, we have various types of singly linked list operations. Okay, that means insertion in various positions. In the header, head insert, tail insert, that means ending, or middle insert, or specific position insert. That means wherever you want, specific position insert. After that we have delete. After that we have display. Every time I'm going to use display. Likewise, we are going to see various operations, how we are going to do. Okay. Yeah, these are all various data structures concept we are going to discuss. The fourth one, we have trees and graphs. Trees and graphs. Based on the time, we go for the trees. Again, in the trees, we have binary tree, binary search tree, and many things, many topics are there. Okay, let's see. Okay, I don't think so. Graphs will be covered, and we will see the trees. This is the total agenda topics which we are going to discuss in the data structures. This is I have given just overview. Just given an overview. Yeah. So let me start with stacks and stack operations. Yeah, we will do this all various types of stack operations. Now, let us move. This is very easy to understand. A stack is a linear data structure that follows the principle called last in, first out. Last in, first out. Okay, that means your input in the last side we are keeping, right? Last in, first out. Whatever you keep the last element, that is the only will come first, come out. How? Say for example, say here, in this case, okay, what is last in, first out? In this case, which one is kept last element? First you push one, after that, okay, the element is 2, and then the element is 3 you have inserted, after that 4, after that 5. Okay, so can you take the first, whatever you entered the first element, can you take now? No. Why? Because there is no way to keep this one to send out, right? Only you have one entry and one same, only one, either enter and they go out, only one entry. Okay, so so which one you can remove first, you tell me? Either you can remove the 5 or 1, only you can remove 5. Okay, so that's why this principle we call it as last in, first out. Whatever the element you insert last, that is the only you can take first. Okay, fine. Now, so in these stack operations, so what are the various operations we have? Okay, that we can see step by step. Standard stack operations. What are the stack operations? Push. Push nothing but what? Simply we are inserting, right? When we insert an element in a stack, then the operation is called as push. Simply inserting an element in the stack, we call it as a push operation. So if the stack is full, then overflow condition occurs. Okay, if the stack is full, then how you can put new element, then we can call it as overflow. We can call it as overflow. So you can understand what is overflow, what is underflow. This is very important. Assume that your maximum stack size, since you are implementing the stack also as an array, assume that your array size is 5. Now you have inserted 5 elements. Still you are trying to push another element. Then can you insert? So your size is exceeded, right? So this operation we call it as overflow. Simply, right? Okay. So when your garbage is full, you are trying to put some more data into that, it will be overflow, right? So if the array size is 5, maximum it is 5. So you are trying to push 6 element, there is no space. So what we call that condition? That is overflow condition. Okay, so when your overflow condition will encounter, whenever your stack is full, still you are trying to insert some more elements, then the overflow condition will encounter, right? Fine. Overflow state, that we call it as overflow. So similarly, when we have underflow state, that means I just removed one by one. That is called pop operation. What is that? Pop operation. If I deleted all, then 4, 3, 2, 1. 1 is also removed. Your stack is empty. When your stack is empty, okay, if you're trying to get the data, if you're trying to pop, if you're trying to delete the data, is the data is there in the stack? No, right? So then, if there is no data in the stack, you are trying to delete the data. That means if you are applying pop operation, then we can call it as underflow state. That means underflow condition is happened. Okay. So here you should understand when is overflow, when is underflow, right? Fine. Simply, you should check before applying any operation. You should check before applying any operation, either insert, like either push or pop. Okay, either push or pop. Okay, whenever you want to use either push or pop, you should check whether your stack is at overflow state or not. When you are applying pop, whether it is underflow state or not. That means you should see your stack is full or not. If not full, then only you can apply the push operation, right? Yeah. If you see this diagram, you can understand better. Yeah. There are some initial things you should understand. When you can say your stack is empty, okay? So I'm using a variable to indicate whether my stack is full or not, right? So that's why my initial variable value is top, is my pointer top, which always identifies where is my array size. Okay. So top equal -1 is my initial value, nothing but there is no element in the array, in the stack. There is no element in the stack. So top equal to -1 initially. When you put something value, that is push 10. So my variable top is incremented by 1. My variable top is incremented by 1. So this is my top variable. My top variable is pointed to 10. That means top value is 0. When you add one more element, when you insert, push another element, always whenever I am adding my elements, my values into this, okay, into the stack, my variable top is incremented by 1. So that whenever you see, okay, your top based on your top value is reached to the maximum size, you can stop insertion. That becomes overflow state. So how you can say the size of the stack with respect to your top variable, and if the stack is full, then based on your top variable, you no need to enter any more elements into the stack. That's the reason I use one variable. Whenever I put some data into the stack, my top variable is incremented by 1. This is manually I given. Is it mandatory to, is it reserved mode? No, I just use my any variable. You can say instead of top, you can say any A value, B value. Just my convenience purpose, I use a variable top for understanding purpose. What is the location of my stack? Okay, what is the number, how many number of elements are available in the stack? Okay, if I top is 1, nothing but 0, 1, 2 elements are there. Likewise, always when you insert the elements into the stack, your top value incremented by 1. This is what I have explained here. When you have the overflow condition, okay, when the new element is pushed into the stack, the value of the top gets incremented, top equal top plus 1, and the element will be placed at that position. Okay, after increasing my top value, then in that particular location only, my element will be placed. Okay, say for example, top equal to -1. Okay, now you want to push 10. In which location I want to put? I have incremented top by 1. Now it is 0. That means top of 0. My element is there. What is the array index? Top of 0. Okay, fine. That means otherwise A of top. In the particular position, I can insert. Okay, fine. So that's the reason I'm going to use this. Okay, or array of A of top. If this array is A, then in which position I will put? A of top. So where my element is there? In the A of top, A of 0. Here, when you want to insert another, before that I will add my top and then put another element. Now top becomes 1. So A of top. Now what is A of top? A of 1. So that element will be placed into the A of top. That means A of 1. Likewise, I'm going to, before inserting, I will increase my top is the indexing position. Then in that index position, I'm going to put the data. Okay. So this is the way I'm going to do stack operation, push operation. Now, what is another operation? Pop. Pop nothing but delete the element from the stack. Okay. Before deleting the element from the stack, we check whether the stack is empty or not. If the stack is empty, can you delete the element? No. Still, if you're trying to delete the element, what we call that condition is called underflow condition. Yes, there is the stack is not empty. That means what? Then we will then simply the element will be simply I will decrease the top position by writing top equal to top -1. That's it. Yeah, if you observe this, you can see. Now, if the stack is full, now what is the top indexing is? Top nothing but index. What is index? 0, 1, 2, 3, right? This is the 3. Now, if you want to pop 40, now what is your top? It becomes 2. That means we have 0, 1, 2 elements only. We have 0, 1, 2 only. Then finally, we have 10, 20, 30. Likewise, you can apply this. Yes, let's see. I'll run this. Sorry, till now, whatever I explained, is it audible to you or not? In the stack operations, till now, whatever I explained in the operations in the stack, push and pop operations, is that clear? Simply just insert, delete. Okay. What are the stack operations? Yeah, insert and delete. That's it. Finally, you are going to display from the array how you are going to display. Okay. So now, so do you know how I'm going to run this program? Instead of directly executing this program, I will explain. Okay, the way I'm going to write this program, I will explain here. See, you know the menu-driven program? You know menu-driven program? Menu-driven program. Menu-driven program is nothing but, okay, it will ask a menu like this. Like One is add operation, subtraction operation, multiplication operation, and division operation. Fifth one is the exit. Have you done like this? Now enter your choice, which operation you want. If you select operation 1, you will get the addition of A and B is, the result is something. If A value is 10 and B value 20, you will get 30. Now again it will ask after completion, it will ask enter your choice. You will give something 2. You will get the resultant of the subtraction. Okay, subtraction, so and so. Then finally, if you give enter your choice, if you give 5, you will exit your program. So this is always, it will give you your choice, and it will display the menu, which option you want. In the hotel restaurant, they will give you a menu for you. Out of that, they'll ask you identify your choice, which item you want. Okay, then whatever you select the choice, based on that they'll give it to you, right? Likewise, I'll give you various operations, and out of that, whatever the option you have selected, you should get the resultant output like this. So these types of programs, we call it as menu driven program. That programs we can do by using switch cases. When you can do this, how can you do this program? We can do by using switch cases. May you know this kind of programs have you done? May you know, have you done this kind of switch cases programs? Can I have a quick response? Yeah. If not, I'm going to tell you now. Okay. And also this stack operations program, I'm going to do like this only. The stack operations program, I'm going to do like this only. How I'm going to do? Okay. So I'll get like this. The first operation is what? Push operation. So what do you want? Whether you want push, pop, that means when you select pop, it will be deleted. Then whether it is deleted or whether you have insert, how do you know without displaying? So that's why I can say show operation. That means display. And finally, I can exit. These are the 4 operations I'm going to run as a stack operations. Okay, these are the stack operations, will be displayed as a push operation, pop, show, exit. Okay, do you know how do you get all the things? Okay, so in the switch cases, I'll give you a brief idea. In the next class, the total program I will explain, and what you're going to do. Okay, first you have to write in the switch. In this switch, you should take choice. Okay, before that, you should read the choice. Okay, and assume that I will read your choice. Okay, enter your choice, you read the choice, and your choice is maybe 1 or 2 or something. What you are going to do? Case. Okay, switch of choice. Case 1. If it is case 1, what is the thing you are going to do? You are going to write in the block of this. What is your operation? Assume that I'll write functions. Push and I'll write break. Okay, this is the case 1. If your operation is 1, then it is a push. Then if your operation is, if you selected 2, then I can say as a case 2, okay, I can say pop operation, break. If you have selected case 3, okay, then I will select case 3. What is the case 3? I may write another function show, then I'll close, yeah, case 3. Then in case of case 4, then I can say it is exit. Okay, if it is case 4, then I can say exit. Simply I can say one message call, I will exit. Okay, exit. You can use exit of 0 or you can use break also, not an issue. Then for every case other than 1, 2, 3, 4, if you select anything, you have default, right? You have default. Here you can mention, okay, whatever you want. Enter a valid choice, right? Printf, you can please select the options 1 to 4 only. Like this, you give some message. Okay, then close. Like this, you are going to do. Okay, all the things where it is available, all the things which are available in the switch. So finally, I'll close the switch. So in the next class, what you will do, you should do some kind of at least add, subtraction, multiplication program, so that to avoid easily you can understand this stack operations. Okay, here you should not understand this logic. This is already done. Okay, we will assume that you know these kind of switch case programs. Okay, now I will concentrate on how to use the push operation. Okay, so every time I will check. So, and another important thing is, what do you understand? Tell me, what do you understand? What are the operations I will do when I can do push? When I can do push, first I can check whether the stack is full or not, right? Whether the stack is full or not. If stack is not full, then only I can insert, right? Yeah, this is the logic. If stack is full, what you can say? Simply I can say, if stack is full, you should say it is overflow. What is the operation? Overflow. So otherwise, in the else part, I will insert the element. I will insert element. This you should understand. If your stack is full, can you insert push operation? No, right? So you get the message overflow. Otherwise, I will insert the element. This is called, the pseudo code, or we call it as, the process. You should understand the process. So in this path, when I can use, what are the operations? What are the, when I can delete the element from the stack? Okay, you should check whether your stack is empty or not. If your stack is empty, okay, here also it is very simple. How can you check it is full or not? There is a variable top. Okay, we already discussed. If your top equal to n, that is total size, then you can say it is overflow, right? If not, you can insert. Simply in the insert, I can say top equal to top plus 1, right? Whereas here, what is the state? What is the empty condition? If your top is minus 1, right? If your top is minus 1, that means what? That means what? Your stack is empty. Stack is empty. If your stack is empty, now I'm trying to explain you theory. If your stack is empty, can you delete? Can you pop? No. Still you're trying to delete. What we call? That is called underflow. Underflow, right? If it is not empty, that means it has some element. Simply you can pop. Pop nothing but what? Simply I am decreasing my top variable. That's it. If I decrease my top variable, nothing but that element is not available. Simply of that I can display. Instead of display, I have used show, right? You can use display also. Any name of the function. Okay. So like this, these are the statements. These are the functions we are going to use in this program. Simply push and pop. Show means display. How will you display? Once you know the maximum size is top, you can display top 2 till minus 1, right? Yeah. So like this, you are going to display the stack elements. Okay, this is the flow. Okay, this is a stack operation as a menu-driven program, which we are going to explain. We will implement these stack operations like push and pop and exit operation with this logic in the next session. And also we will do simply it is reverse queue operations. This is last in first out, the queue is first in first out. Okay, so both stack and queue we are going to implement in the next class by using arrays concept. After that we'll go for the linked list. Okay, so till then, happy learning, and I'm going to stop this session now. And please practice with this kind of menu-driven program for the next session to make easy. Okay, fine. Thank you very much. Yeah, I'm stopping this session.
Sir, shall I end the session?
Yeah. Hello,
Hello.
ma'am. Yeah, ma'am.
Yes, sir. Yes, sir. Okay, sir.
Yeah.
I am ending.
Yeah,
Thank
I'm
you,
leaving
sir.
this session.
Thank
Yeah, thank you, ma'am. Yeah.
Okay. Thank you, students. Have a nice